text in Teams today that there's a sketchy email going out, and we spread it word of mouth whenever this happens.
Oh, there's a sketchy email?
Yeah, it's under Positive Vibes MD.
Wait, let me see. Did I get it?
Well, maybe you have it, maybe you don't.
We can only
If you
hope.
see it, don't open it.
Wait a minute, here it is. Let me open it and see. Oh, it's got some positive vibes. No.
No, but there's an attachment in there that we said don't click.
Oh, I shouldn't click the attachment? What'll happen? Let me find out. No, I didn't get the email, so sadly. I get emails from like Dr. Spalding, our former president. I'll get it. Like, click this, I need your help. Yep.
Some people don't. If you see it, don't touch it.
Okay.
You'll have to
Okay, so Cooper, what is this? Part of your job or something? Or wait, as you work for Motherboard or the former Motherboard?
Spread word of mouth.
Okay. Okay, great. Thank you. So we can look forward to these public service announcements. Wait, you actually clicked on it? Did you have positive vibes?
No.
Okay. So now you need to take all of your devices to the hub. Is that right? When you click on an attachment like that, you take all of your devices.
Stop by the office and
They'll.
how your account is.
Okay. Okay. So you will not get positive vibes from the podcast. Okay. Thank you for this moment of joviality. We need to move on though. So let's go on to this. That's not our quiz. Our quiz is over there. So are there homeworks though? I guess the homework was easy. Wait a minute, Ryan. You said it was so easy.
37.
37. Yeah, I looked at this morning and I was like, wait a minute, we never went over that. And I thought, well, we might be slowing down this week, which is fine. It's not that, the 37, I got to admit that things like those last few of the applications, those are the ones that I thought would be fun for me, which means they're not that fun for you. And they might not be all that useful to you either for the rest of the class, but they're kind of cool. So we might as well do them. Just a sec. Let's pull this up. Let's take a quick look at 37. Whoops, I just turned off my iPad. Just a sec. Let's turn it back on. Come on. Okay, give me a sec. I'm just going to take a picture of this so I don't have to redraw it. There we go. Good enough. Okay. It'll just take a sec to make it look better. There we go. Because we're going to draw on this. So there's the drawing for 37, and it says that the hoist weighs 350 newtons. Okay, so that means we have this thing is pulling downward. Whoa, come on. There it is. Downward, 350 newtons. And there is tension in each of these. Yeah, I had one in my PowerPoint ready to go. I never did it last time, so my apologies. This isn't that bad. Basically, what you're just doing is you're balancing forces. Probably the physicists here are looking at this thinking, yeah, that's easy. It's what we did back. You remember the force tables? I don't know if you remember these are like the things you have, like masses that you hang off of the side of a table, these circular tables, and you try to make things balance. It's kind of fun, the vectors. So we're doing the same thing here, but doing it mathematically. So let me just call these something. We're going to call this one A. This one is going to be vector B. So A is going to be this vector A1, A2. And then B is going to be the vector B1, B2. Now, let's see if we can work this out in terms of this 3 and the 2. The 2 and the 3 are really irrelevant, so I'm going to ignore those. I don't even know why they have them there. So they're completely irrelevant. What matters are these angles. So the angles are what matters, because that's going to tell me sort of how I'm going to form these two vectors. So we're going to call this is 38 degrees. And so it turns out that the vector B, because it points in the direction of 38 degrees, it's going to be some number, some constant. So this is the part that we didn't get to last time, but some of you are going to be like, yeah, that's obvious. But yeah, if you're not a physicist, maybe it wouldn't be obvious. Anyway, that's going to be some number we're going to call this, I probably should have used capital, well, we'll use little b times the cosine of 38 degrees, and then little b times the sine of 38 degrees. So this vector, if you think of it as a right triangle there, that vector, however long it is, and it's not 3 meters long. I mean, the cable's 3 meters long, but we don't care about that. What we care about is how much tension is in that cable. So there's a right triangle that it makes here. Think of this as a vector pointing, it's standing for a force, and so that force has a component going this way and a component going this way, and you can see here from this right triangle that the x component is going to be whatever the length of this times the cosine of the angle, and the other one of the sine. So the same thing goes with a, only with the a vector. I'm going to have little a times, let's see, this is 50 degrees, but we're going backwards, and so I'm going to use negative a times the cosine of 50 degrees, or you could use a times the cosine of 130 degrees if you prefer, but I'm happy to do it this way. Wow, that purple doesn't show up very well, does it? Oh well. And then this is going to be a times the sine of 50 degrees. Okay, so here's the deal, is this along with this 350 Newton, so that's going to be the, what did they call it? They called it a hoist. The hoist, I'll call it H. The hoist is this, 0, negative 350, because it's pointing straight down, that mass going straight down. We want these three, bah humbug. Anyway, we want this to b plus a plus h to equal 0. It should balance out, just like those force tables you played with in physics class. And so let's add them all up. Let's see, we have the x component, b times the cosine of 38 degrees, that's a minus a times the cosine of 50 degrees, should equal 0. And then b times the sine of 38 plus a times the sine of 50 should equal 350. Sorry, I should have put the 350 on the other side and moved it, but yeah, whatever. So those two, when you add these up, you should get 0. So yeah, whatever, you can figure it out. Okay, so you have two equations, two unknowns. You have a sine and a cosine, and then once you figure out what A and B are, those are the tensions in the two ropes. This is too painful for me to do in 2 minutes, and I don't want to take the 5 or 6 that it would take to do this. But hopefully you can see you can solve this. You can do this on your calculator. It's not that bad. So that get you through it at least the right idea. And if you don't get it fully done, you get the right idea. Like I said, this is, especially when you get to the application problems, oftentimes I pick those and I think, oh, that'll be fun, not realizing that it will not be fun. So it'd be fun for me, but also it's fun for 2 or 3 of you. So I don't want to take the fun away from the 2 or 3 that really enjoy this. All right, anything else from this that we need to look at? So 37 was really the worst. So let me just ask you this, because you know how it is. The quiz is not going to be fun. The quiz is going to be easy. So the quiz, you know how to figure out which of the points is closest to the XZ plane, right? You know how to find the distance between a point and a plane, or a point and a point, distance formula. You can do this. It's simple. And you can figure out the sum of 2 vectors and the magnitude of a vector. I'll bet you can do this. You'll be fine. But is there anything else? I don't know. Yeah, so let's do this. It'll be okay. And by the way, when it comes time to here, you can send these. So Emily, when it gets to you, just give it over to Darren. So you don't have to. If you want to grab this stuff, like when you're done with your quiz, you can, or you can do it after class. It's no big deal. Just send that all the way over. So all the way. I'll come to the middle to get the homework. Let's see. You guys have too many. Oh, wait a minute. This is probability. Some of you, I put probability. I'm sorry, in that, if it says probability, that's not for you. Sorry about that. Yeah, my bad. I got the wrong one for you guys in that. You know what, everyone else got the right one. Sorry. You want the?
I'll do the probability one.
No. Let's give you the right one. Let's get those. I'll do that. Okay, so does everyone have one that's got vectors, calculus? Probably bringing all the quizzes. I have an extra bit. I'll be there in a sec. You've got this. It says probability as well. Okay, there's that. Notice that's not it. Get it here. Let's do this calculus. Okay. All right. Okay, great. This is for me. All right, I'll take it. This one for you. Very good. Well, when you do finish, feel free to turn your paper over, send it towards the middle. Another FERPA violation, by the way, so let me know if they're all minor though. It'd be a misdemeanor, not a felony. Wow, everyone's going up there now. It's exciting. Good job. Good job. Find a good stack in there. Dig deep and get it all. System working? Working. And hopefully you're coming down the home stretch. We'll so now is the time to panic if you're still working. Normally I say you don't have to panic, but yeah. Oh, you got something for me? I'll be the judge of that. You got something for everything? You want to put something down there? Put 3 numbers and hope for the best. Yeah, give it a guess. It's always fun if it's right. There's someone back there who did the same thing. Just got it right by mistake. All right, nice work. Okay. All right, anyone else? Did I have them all? All right, let me staple them together. We'll go over. There it is. Yeah, some people want to write. Yeah, remember, I'm a mathematician. I don't like to read, so the less you write, the better. So notice that mine has almost minimal. Unless I ask you for an explanation, all you got to do is just tell me the answer. So point C, and of course this is because the XZ plane, the distance from the XZ plane. Wait, that's that wall is the Y value. And so whichever Y value is the smallest, it's going to be point C. The YZ plane, that's going to be this wall. So this is the X value. So whichever X value is the smallest, and it's A. And then the distance from point B in the XY plane, that's the floor. So that's going to be a distance of 1 for point B because the Z value is 1. So far, so good? Not bad. Hopefully everyone got those right. And then we move on to the vectors, adding vectors. I hope you did this one okay. You're just adding the components, right? Simple. And then this next one, a little trouble. This is just distance. It's a distance formula. So I took vector u. Some of you did this vector for your when you did the distance, which I commend you for doing that, and you got the distance correct, but it was that u that I was looking for. So 1 squared plus 2 squared plus 3 squared, square root of 14 is that distance. And then finally, this last one, answers will vary. So, but I have some examples. The way you would get a vector that is parallel to this is you just take this and multiply it by some number. Pick any number you want, and that'll give you another vector that is parallel to this. So you could multiply it by -1. That's the easiest way to do it. is multiplied by -1, you'll get this, -1, -2, -3. You could multiply it by 2. That would work as well. Get 2, 4, 6. You could, by the way, so what you're looking for is you're looking for a vector where any vector where you take whatever number here is it and double it and then triple it, and you're all good with that. I don't care what it looks like. You could have done this if you wanted to be clever, pi, 2 pi, 3 pi, or use e or the square root of 5. You could divide. You could divide everything. I saw someone actually turn this into a unit vector, which is great. Divide this by the square root of 14 and is a unit vector, meaning that it's 1 unit long. That's beautiful. So this one, there it is, etc. So there's a whole bunch of, pick your number, multiply it by that number, and you get a vector that's parallel. So there's parallel. So for whoever it was that was asking me, what's parallel? There you go. So let's move on to the dot product. And some of you have used the dot product and you're excited because it's going to take you no time to learn this. But let's do the dot product together. And to get us into doing dot product, I want to answer these two questions. The first one is pretty easy, so we'll do that one first. And then the second one is harder. So let's take a minute and take a look at the first one and see if you can work that one out. I'm just copying this to Notability so it'll be easier for me to write. Hold on a sec. Paste it. There it is. Oh, it's cut off. There it is. Okay, so let me draw this for you. So if you're not sure what to do, we'll call this question number 1 and this question number 2. So let's do question number 1 first. Find the angle between those two vectors. So here is what we're looking at. We have the vector 1, 3, which is this vector approximately. So we'll just call this 3. This is 1. This is the vector 1, 3. And then the vector 5, 1. So here, let's see, 1, 2, 1, 2, 3, 4, 5. So let's see, 5, 1, that would go to right there. Good enough. So there it is. That's the vector 5, 1. And I want to know this. What is that angle between those two vectors? Take a minute, see if you can do it. I'll bet you can. Won't take too long. We work with a friend if you'd like, or you can work alone if you are a loner, I guess. But just get that angle. However, there's a bunch of different ways you could do this. But I'm sure you can come up with something, some idea. This out. Weird. Oh, I haven't done this yet. Oh well. By the way, I always love radians, but if you've got it in degrees, I'm happy that you've got something. So degrees are fine, radians are even better. Well, I know some of you have no idea what to do, and some of you are already done. So let's find a volunteer here. Emily, do you have any ideas as to like where to start? Just get the first step.
I did the inverse tangents of each of the vectors
Oh.
and then subtracted them.
Oh, that's so beautiful.
Way to do it,
That's
but
perfect. That's amazing. Okay, so I'm guessing you were thinking in terms of these two triangles that I've got drawn here. So if you draw these triangles on here, you can say, okay, this green triangle can be inverse tangent of, let's see, tangent TOA. Yeah. Opposite over adjacent. You'd think I'd know this by now, but I always have to think through. So opposite over adjacent. So inverse tangent of 1/5 will be that angle. And then this dark blue is going to be the inverse tangent of 3/1, right? Nice. Oh, do you have those? Did you do degrees or radians?
I started in radians because that's what my calculator was.
Oh, that's fine.
I got like 1.05, which is about 60 degrees.
For the difference. For the whole thing. Okay, very nice. Good job. So 1.05 radians. So whatever your radians is. Does everyone see what Emily did? This is perfect. Beautiful. Does anyone have anything? Now, there are other ways to go about this, but you can see I had drawn those in anticipation that would be the way that is most popular. But there may be other ways. Does anyone have another way that you know to do this? You got one, Kelsey?
I don't fully know what I did, but it worked. I divided the x over, I divided the y over the x for both the vectors. And then I did something, I multiplied that by
y over the x. Just a minute. 3. So you did this. Y over x. Okay.
Yeah. And then I divided 90 by those numbers.
Okay, this sounds like you got lucky. I mean, this happens sometimes. And it's a problem for like when you make a test or a quiz is to avoid a problem where someone could get lucky. I don't know. I don't want to say that that's for sure what happened. It may be that you happened upon the formula that we're going to teach today. So, but but there's a name for the formula we're going to teach today. But hey, let me show you the just a sec. Let me get rid of these two triangles. Oh no, I got rid of too much. Just a sec. Can I just get rid of the? Let's see. Hold on a minute. Let's see. Okay, get rid of that. Oh, sorry, I got to change to eraser every single time. There we go. Okay, so let me show you. Before I go on though, does anyone else have something that they did that was a little different? You did something different?
I did the dot product.
Oh, don't do that. Yeah, there's a formula involving what's called the dot product. But the formula, this dot product, this mythical thing that Claire used, it's related, or it's not related. It is directly descended from a formula that you may have learned, maybe not, that involves this distance here. So that distance there, let's get that distance just for fun. So that distance, let's see, or here, we could do this. This vector is the vector -4 and 2. Okay, so that vector is -4, 2, because you're starting here at that point, ending at that point. So I just did 1 minus 5 gives me -4, so 4 back, 2 up. So you see I've got a triangle here. It's not a right triangle though, but there's a trick that you can use with triangles that are not right called the law of cosines. So let me remind you of the law of cosines. Law of cosines. So we'll call this A, this is going to be B, and this will be C. The law of cosines looks a lot like the Pythagorean theorem. And I like to say that the law of cosines is kind of like the Pythagorean theorem for triangles that aren't right. Well, they don't have a right angle, but that they're not the way we would like them to be. So this is kind of like a more inclusive Pythagorean theorem. So you have the Pythagorean theorem that you're familiar with, and then the law of cosines gives you a hint as to what you're going to do here. We're going to make a slight correction. You see that subtraction there, and the slight correction is this: 2ab cosine of whatever angle is there. So we can use this to compute the angle there. And we'll use the cosine. It'll end up using the inverse cosine. Now, let's actually do this for the next one, because the trouble with this picture is that this picture is flat. This picture is in the plane here. And so we can do what Emily suggested. We can make a triangle in the plane, and we can compute this angle, and we can subtract it from the other angle. But imagine what happens when we have these two vectors that are not in the same plane. They're pointing in two disparate directions, and if we want to come up with the angle between them, we're going to have to do a little bit more work. Now, well, let's see. Can I pull this up really quick? Oh, yeah, there's homework. Just a minute. There it is. Let me see if this will be really quick. If not, I won't belabor it. But Calcplut 3D, we can actually draw these two vectors. So I need to be able to see my vectors. So we go to Calcplut 3D. Or no, it's Calcplot 3D, but I guess that the website is Calcplut. So let's get rid of this beautiful surface. We'll do surfaces eventually. And I'll just put two vectors. I'm going to put the two vectors on here so that you can see them. So the first vector was the vector 103. Change this to 103. I continually take off my glasses and then I regret it. Here we go. Okay, so there's that. And then I will put the other vector on here. Give me a sec if I can figure out where my mouse is. And the other vector is the vector, hold on a sec, -4, 5. So -4, 5, and 1. Okay, so that's that one. I'll make this a different color so that we can see it easier. So we've got the red vector, we've got the blue vector, blue, close enough, blue, and I only see one vector there. Why do I only see one vector? I think I need to zoom out. Oof, it's not right. Something's wrong.
Is it like getting mad at you because you don't have a space in that one?
Maybe that's it. Space it. You would think that would be fine. Initial point. Ah, that's better. Yes, yay. Yeah, there they are. Okay, now I can zoom out. Zoom out. Zoom out. There they are. Okay, so now you can see. You can sort of see that the vectors form an acute angle. It's quite a sharp angle, so we should expect this angle to be small, like 20 degrees, maybe even less than that. So there you can see, but it's going to be hard to actually compute that angle because there's no reference line like there is in 2 dimensions. So 3 dimensions, what am I going to do? I mean, if I measure these against the y-axis, you know, the angles, where's the y-axis? It's pointing out down here. This angle is going to be this. This is going to be kind of at a funny angle. So it's going to be hard to do this, I guess is the point. So that's where the law of cosines comes in. So let me do this really quick. And then we'll get the formula that everyone wants to, that's all you really care about. But bear with me just for a minute. So using the law of cosines, let me draw these two angles, or these two vectors. So there's my two vectors. And then this is going to be here. Give me a sec. I need the actual vectors. 103, 103. And the other one is -4, 5, -4, 5, 1. And then I've got this, so this is going to be u, this is going to be v, if you will. And then this is going to be u minus v. Is that the way it works? U minus v? I think that's the way it's supposed to be. But anyway, this is going to be the vector -5, and then 5, and then -2. There it is. Okay. So we've got these three vectors. This is not to scale. This is not oriented properly, but it's just sort of to help us to draw these. This is the angle I'm interested in. And so using the law of cosines, what I'm going to do is I'm going to have the magnitude of u minus v squared. That's the stand-in for c. Notice that the c up here is the opposite from the angle, so that u minus v is equal to the magnitude of u squared plus the magnitude of v squared minus 2 times the magnitude of u times the magnitude of v times the cosine of the angle. So I could go through all of this. In fact, I did. Let's see, do I have it on the PowerPoint? I hope so. That'll save me a lot of writing. Oh, I don't. Why did I not have it? Well, yeah, I don't know where it went. I used to have it in my PowerPoint, but apparently I deleted it at some point in my past. So here's what happens is through a lot of algebra, which maybe that's why I deleted it in the past. Through a lot of algebra, you can rearrange this. And I know it seems fantastical that I can do this, but bear in mind that I can do algebra. That is to say, I can take u and I can write it as u1 squared plus u2 squared plus u3 squared, where u1, u2, and u3 are the components of u. So I could do all of this and I can get all this to work out. But what you're going to find is that the cosine of the angle ends up equaling this. You end up with u1 times v1 plus u2 times v2 plus u3 times v3. This is after doing a lot of math, a lot of arithmetic, and algebra. A lot of stuff cancels. And then down here, you have 2 times the magnitude of u times the magnitude of v. So there is the formula for the cosine. And I can actually do this really quickly now using these two vectors. So let's see, this is going to be the cosine of my angle. Will be, so following along, u1 times v1 means take the first component, multiply them together. So it's going to be negative 4 times 1 plus u2 times v2, that's 5 times 0, and then 1 times 3. And then this is 2 times the magnitude of u. The magnitude of u looks like it's going to be 25 plus 16 plus 1. 25, 26 plus 16 is 42. Square root of 42, I believe. And then the magnitude of v is 10. Well, square root of 10. Yeah, I guess that something that I used to have in my PowerPoint, but I don't now, is this part here. Is going between those two, there's lots of cool algebra. And so this looks like it's showing up here like magic, but it came from the law of cosines and doing a bunch of algebra, and you get this thing. Anyway, doing this, we're almost done. So the cosine of the angle ends up being negative 4 plus, that's going to be negative 1 over 2 times the square root of 420. And so, wow, that's, why is that negative? Oh no, this isn't working out. Did I make a mistake somewhere? Let me see. Yeah, this is not, it shouldn't be negative. Well, let me do it anyway. So negative 1 divided by 2 times the square root of 420 is negative, yeah, this is not the way it should be. Just a second. So this is going to be negative 0.02439. And then I do the inverse cosine of that. Yeah, this is not right at all. Answer. I'll have to go back and see what's wrong. I got 1.59, that's the angle, 5, which is just over 90 degrees. And we saw the picture, so either I typed, maybe I should not trust the picture. Let me go look at the picture again. Because that's definitely not 90 degrees, is it? Hold on a minute. Over here. Yeah, that's an acute angle. What in the world? 1, 3. Did I type all this right? 1, 0, 3. And -4, 5. 1. I don't trust this. That doesn't look right. Just a minute. The -4. Yeah, that doesn't look right at all. What in the world? Yeah, I don't know. I thought that this was a good tool. I was so excited about it. I'll have to figure out what's wrong with it. Yeah, that can't be right because the angle is close to 90 degrees. So, yeah, whatever it is. So yeah, let's move on. Let's move on to the examples. Okay, so here's the deal. This formula, there's the formula for the angle, or cosine of the angle. This thing right here is so useful, and it pops up elsewhere. You can't, oh yeah, you can see it. So this thing is so useful, and it pops up in other formulas. Yes? Yes? What?
Well, so I was just like knowing the dot product formula. Where's the 2 coming from? Because in the dot product formula, it's just A dot B over AB. There's no 2.
Yeah, where's it?
And that's why I'm confused.
Oh, it's because I didn't do my algebra right. Yeah, that may be the problem. Yeah, the 2 got canceled. Thank you. Yeah, I'm sure it would come up in the PowerPoint in just a minute. Yeah, there's the cosine formula. That may be the problem. No, there's still a problem because it's still going to be negative. Still going to be an obtuse angle. So, yeah, it's just off by a factor of 2, which isn't that big of a deal in this case. In this case, other cases, it's still close to 90 degrees is what I'm saying. But anyway, yeah, my bad. I should have derived the formula in full. I think what happened is a few years back, I realized no one cares about the derivation of the formula. And so I stopped including that in my PowerPoint, but I guess I shouldn't have deleted it. But yeah, so because this thing is so useful, this product, this dot product, we call it the dot product, and it shows up in the formula for the angle. Here's the angle, yeah, magnitude of A times magnitude of B. So my bad there. Yeah, I was so excited about the derivation that I should have, I don't know what I should have done, but no way to go back now. Okay, so there it is. And so dot product here is you just multiply. So let's actually do a few dot products to see if we can practice this. Here are some, no, we don't care about that. Here's an example. So let's go ahead and do these dot products just to see how it works. To do a dot product, I'll do this one and then you'll do the next one. What you do is you multiply the components together. So we take those 2 components, 2 times 3, and then add that to the next pair of components. So 4 times -1. 4 times -1, and that gives you 2. There you go. So pretty easy to do a dot product. So we'll get to the application of dot product here in a minute. Let's do these 2. So go ahead and do that one, and I'll pick a rando to help me out. So you're doing it better than me. Yeah, the derivation of the dot product formula is so beautiful. And yeah, I should just avoid it from now on completely and just say it magically came down from heaven. Instead of, I mean, because that's what the engineers, that's what you, the mathematicians are your high priests, and you take what we, it's the word of God, right? All right, let's see. Who's the next volunteer? Pick another one. You're not here to do it, but you would know. Max, you know. How do you do this dot product? Sorry, -4 times -1/2, right? Yeah. Okay. 6, very good. 6, dot product between those 2, very good. And then one more. since we're going to be into this and all the engineers love I, J, and K, just remember that this is just a shorthand for this vector, and it will become super useful on Tuesday. So tomorrow it'll be, whoops, I forgot my 0, didn't I? Just a minute. Let me get rid of the stuff here. Just put this back in here. So this is, oh, it came, oh, why will that? Well, there it is. And it's just writing. I'm trying to tap, but it's just writing. That's one of the things I don't like about the iPad with PowerPoint. But anyway, yeah, this is 0 to -1 is that one. So I'll try again. 0 to -1. There you go. And we're doing the dot product of those. So let's go ahead and find another volunteer. Here we are. Kelsey, do you want to talk me through this one?
So you take 1 times 2 plus.
Sorry, it's the way I've written it is
1
bad.
0
Yeah, 1 times 0 is 0. Good.
plus 2 times 2
Okay.
plus -3 times -1.
Okay, very good. So we got 7 there. Yeah, so that's why this, even though this is useful in certain settings, when you're doing a dot product, sometimes it gets confusing as to what you're going to put this here. So there we have it. So you might say, well, what is a dot product useful for? Well, it certainly is useful for finding the angle between two vectors. So we'll do an angle here just to make sure that we can do this together. So the formula here is that the cosine of the angle is the dot product of the two vectors divided by the magnitudes. And then that's going to lead to another thing that's useful about the dot product. So dot product will do the, I'll just remind you, the cosine of the angle is the dot product divided by the magnitudes. All right, so we'll do dot product first. I know some of you are already done with the whole thing, but let's do the dot product just to make sure that we all have this now. So jot down your dot product. Matthew, do you have your dot product? All right, how did you get that? All right, very nice. And that gave you 2. Good job. I just wanted to write it down for anyone who wasn't sure. Now we need our magnitudes. Claire, do you know the magnitude of A? Very good. So it's the square root of 4 plus 4 plus 1. So take those, doing the distance formula. So that's 3. And then one more. There we go. Christopher, do you know the magnitude of B? And that's going to be 5 squared, 25 plus 9 plus 4. Add them up. And wait, it's 38? Yeah. I guess we both did the math wrong. So that's 38. Good job. Okay, so then the final answer here is that the cosine, this is the cosine, it's not the angle itself. So when you do this, you always have to do one more step. So this is going to be 2 over 3 radical 38. The last step is to use your calculator, punch this in, and make sure you write down the units, because if we're in degrees or radians, you'll get a different answer. So I won't bother. I'll see if you did. Let's see. Give me a sec. Oh, click. Joshua did. Joshua, did you use your calculator with this one? What did you get? 83.8 degrees. All right, very nice. 83.8 degrees. That sounds reasonable. So there are several other properties. One is, and then we'll, so you may have to look up in your book when you get to the homework, but just one more property just to mention, and that is that we can tell whether two vectors are perpendicular by looking at their dot product. In particular, what you do is you do the dot product, and if you get 0, then for sure they're perpendicular, because the cosine of an angle, the cosine of a right angle is 0. So if the dot product is 0, then the cosine will be 0, which means that you'll have a right angle. So you would just do the dot product, and here the dot product is not 0, and so no. not. Okay, so the rest of it, we'll just pick up the pieces tomorrow. I'll try to do my best to get it together myself. I'm going to stop the recording in case you want to whisper things to me late.